let's move on. Two terms which you've certainly seen before would be rate and rate of change. Rate is just a ratio of two quantities, and a rate of change is when the ratio involves numbers that have differences. The rate of change often has units, and some examples given here just to make some connections. Could be how fast something is moving, could be the amount of money made per hour, it could be the filling rate of something in volume units per minute, could be density unit, grams per cubic centimeter for different types of chemicals. Now, so in linear relations, the rate of change is the ratio of change in the dependent variable. We call this the vertical change or the rise to a change in the independent variable, which we call this the horizontal change, and specifically the word run is used. Now, rise and run can be negative depending on whether we're moving down on a graph or from right to left. Typically, when we move on a graph, we always move from left to right, and so the run will always be positive. The rise can be positive or negative depending on how the graph behaves. We always want to use 2 points from a graph or data table to calculate this rate of change. Rate of change is really calculated as a ratio, of course, and we can either consider it to be a ratio of y and x changes, or we can call it the difference in y divided by the difference in x. We can call it the rise over the run, or we can also call it the y2 subtract y1 over x2 subtract 1 formula that you've certainly seen before. Now, when we want to calculate rates of change, quite often we'll use a differences table. Or in this case, if we're specifically looking at the increases or decreases of the y value, for a 1 unit increase in the x value, that's called a first differences table. If we go beyond that and calculate more differences, then we would be calculating a differences table, but they might be second differences. First differences specifically, we're subtracting y coordinates. So here's an example of one which you have in your handout. Here x is increasing from 1 to 2 to 3. Y is decreasing from 10 to 7 to 4. We can see the change in y is constant at -3, and we discover that when we calculate the first differences. The only thing we really have to make sure of in the first differences is that the increment in x is 1 unit, okay? So for 1 unit increase in the x, the change in y will be our rate of change. So in this case, shown graphically, this would look like this, a negative slope, and the line would drop fairly steeply. So in summarizing the connection between rate of change and slope, here we have for lines, any line will have a constant rate of change. That will mean that the first differences will be equal. We can see here that both first differences are -3. The slope will also be equal, and the slope specifically for a line represents the steepness and the direction. The direction would be attached to the sign. So the negative of the -3 tells us that the line is dropping, so that's the direction of the line, and the 3 tells us how quickly it's dropping. Now, a special case would be horizontal line. Horizontal lines have constant rate of change, but in this case the rate of change will be 0. The first differences for a horizontal line and the slope will be 0. Horizontal lines are flat, so they are not neither dropping nor rising in the y direction as x changes. And the last point to make here is that for nonlinear relations, they have a varying rate of change. The first differences are non-constant, and the slope will also be changing from point to point. With nonlinear relations, we can still calculate a rate of change between 2 points, but we would call this an average. So in the textbook, when you come across questions that ask you for an average rate of change, it just means looking from point to point where the slope may not necessarily be constant. This is a review lesson, so that's all it needs to be covered for this topic. You've seen this content before. The assigned work for this section will be looking at just some introductory type questions with the partner. When you get to 8 or 13, you're going to choose one of those, but you're going to come back to the other question that you didn't look at with a partner and do on your own. Independently, you'll be completing 10, 11, and that third question, 8 or 13. And as a class, we will work with the graphing calculator to see how we can use the technology to calculate differences from numerical tables of values, and also using the graphing calculator just to see the shape of curves that exhibit constant rate of change or varying rate of change. So that's it for this introductory lesson. We'll see you in class tomorrow.